There's a lot of terminology associated with polynomials. For example, we have things called monomials, binomials, and trinomials. So monomials are things that consist of just one term, like x, or 2x cubed, or -3, or 1/2 xy, a squared, b to the fifth, and -8 m cubed times n. Those are all monomials. So contrast that with binomials. These are things that consist of two terms, like x plus 1, or a squared minus 4, or mn minus p squared, or y squared minus z cubed over 3. You could think of this as 1/3 y squared minus 1/3 z cubed. It would be the same thing. Or -2x minus 7y, or 6 plus b to the fifth. In each case, we have two terms. And a trinomial, as you might guess, is something consisting of three terms. So like x cubed minus 4x plus 7, or a plus b plus c, or ab squared minus 3b cubed plus a squared b squared. Or, this complicated thing, lots of fractions. 3/2 x squared plus 1/5 y squared plus 4/7 z squared, or 9 minus mn plus 7m squared, or 2 plus x plus y. So in general, a polynomial is a monomial or a sum of monomials. So since a binomial is a sum of monomials and a trinomial is a sum of monomials, binomials and trinomials are also polynomials. So let's look at this one. 3x to the fourth plus 2x cubed minus 7x plus 5. That's a polynomial. We would say that the coefficient of x to the fourth is 3. So I'm looking at the x to the fourth term, and I see a 3 out front. That's the coefficient. Similarly, the coefficient of x cubed is 2. The coefficient of x is -7, and the constant term is 5. Notice that I don't have an x squared term in here. So I guess you could say the coefficient of x squared is 0, but it wouldn't really make sense to talk about it since it isn't even here. Now let's look at monomials and the degree of the monomial. So for example, 4x cubed. So the degree is this power 3 right here. We're looking for the power of the whole thing. So in that case, the degree would be 3. But what if you have something like 2a squared b? Well, you can think of this as a squared and b to the first. And then to get the degree, think of adding the powers together, 2 plus 1. So this would also have a degree of 3. How about -3 x to the fifth, y to the fourth? So again, we look at the 5 and the 4, and we would say, okay, 5 plus 4, that's 9. How about x? Well, x is really x to the first power, so we can say the degree is 1. How about -6? Well, we could think of this as -6 times x to the 0th power. And if you remember, anything to the 0th power is 1. So that's why this ends up still being the same thing. So in this case, the degree is 0. How about 5a squared, b to the 7th, c, d to the 4th? Okay, so we have a 2, a 7, there's a 1 here from the c, and then a 4. So we would be adding 2 plus 7 plus 1 plus 4. And if you do that, you get 14. Okay, so that was great for monomials. What about polynomials? Well, in general, we can calculate the degree of a polynomial, but first we have to make sure that the polynomial is simplified. So here's a polynomial that is not simplified. It's not simplified because there are some things that we can combine here. There are some like terms we can combine. So for example, we have a 6x squared here. I'll put a little check underneath that one. And we have an x squared here and a minus 2x squared here. So I can kind of group all those together. I have a 6x squared, and then I have an x squared, and then I have a minus 2x squared. And then I have a minus 3x, so that takes care of that. And then I have a 2 and a -5. So I have a 2 and a -5. That takes care of those. And now I can simplify this. So I have 6x squared plus x squared, that's 7x squared, minus 2x squared, that'll be 5x squared, The 3x is still 3x, and then 2 minus 5 is negative 3. And this is a polynomial that is simplified. So now that you know how to simplify polynomials, we can look at the degree of a polynomial. So if we have 8x squared plus 3x minus 4, we're going to look at the highest power. So in this case, the highest power that we have is 2, so I would say this is a second degree polynomial, or the degree is 2. If I have 3a to the 5th minus 2b cubed minus c, well, let's see, I have a 5 here, I have a 3 here, and this c would have a 1 here. 5 is the biggest, so 5 wins. How about this thing? Well, this gets a little more complicated here. We have to look at each term individually. So this monomial would have, well, there's a 1 here, so 1 plus 2, that would have a degree of 3. This one, we have a 3 and a 2, that's a degree of 5, and this is 1 and 1, that's a degree of 2. 5 is the winner since it's the largest. How about 6ab squared minus 7a squared b? Well, the ab squared, the a has a 1, 1 plus 2 is 3. And then a squared b, the b has a 1 power here, so 2 plus 1 is 3. In this case, it's a tie, so we say the degree is 3. How about x plus y plus z? Well, they're all to the first power, so in this case, every term has a degree 1, so overall we would say degree 1. How about x times y times z? Well, in this case, since the x, the y, and the z are each to the first power, the degree would be 1 plus 1 plus 1, or 3. Okay, let's look at this polynomial. 5x to the 5th minus 7 plus 2x squared plus x minus 9x cubed plus x to the 6th. So we see the powers here, but they seem to be in all kinds of order here. We have a 5, a 5th power, and then we have the constant, and then a square, and then a first power, and then a cube, and then a 6. It'd be nice to sort of write this in a standard way, and we have a way to do that. We call it standard form, and that's where we write it in terms of decreasing powers. So in this case, the 6 would come first, so we have x to the 6th, and then we would have our x to the 5th, and then our x cubed would come next because there is no x to the 4th power up here, and then our x squared, our x, and then our constant term, our negative 7 at the end. And now it makes it very easy to see the degree because the highest power is the first monomial term there, and so we see that this has a degree of 6.